See, tell me, come on. It is just function of a function. Eh? See, log x is function of a function because instead of x with log, we got log x again. So we have to differentiate this log x first. The derivative is 1 by x. Now what we have? Log x.
Log x. 1 by x. 1 by log x.
1 by log x. And we can write as 1 by x log x. Right?
1 by x, 1 by
mute.
Log x.
Mute. Okay. See, log x. Log x is function of a function. So we have read the derivative of log x, which is 1 by x, times derivative of log x is 1 by log x. Right? If it was log x, 1 by x. Log sin x, 1 by sin x. Log x, 1 by log x. Hope you understand. Okay. Now, see, we were discussing things like this. I was saying something. See, the first thing you as x changes, sin x and this x will change. Both will change.
Yes. Yep.
Right?
That's true.
So, see, d by dx of sin x is an ordinary thing. It's an ordinary
Yes.
thing. See,
It is.
with x, sin x will change.
Yep.
It's easy to understand.
Of
So,
course.
the problem is d by dx of sin x all raised to x is a different function. See, here when x changes, sin x will change and its exponent will also change. You understand?
Right. Yeah.
So, if I say there will be a double change, you agree or not?
Of course, it will be.
Yeah. So it's like this. You can mute now. So
Okay.
we cannot differentiate a function with a function in its exponent. Right? That's the basic thing. So we cannot differentiate a function keeping another function in its exponent, because if we keep exponent as a function, the change will be double. We cannot find the rate of change. Hope you understand. If you understand, type yes or no. No response, no one. If you didn't, you type no. No. So tell me that. See, if we keep this x here, right? See, we are trying to discuss and understand this one, right? If you study mechanics, it will be easy, right? But see, listen. If I differentiate sin x, the meaning is easy, right? I'll give you an example, right? D by dx of sin x. So x is approaching to be pi by 4. Pi by 4. So it will become sin pi by 4. Right. This function will become a sin pi by 4. It's easy to understand. But this function will become sin pi by 4 all raised to pi by 4. So the change will be double, means extra. I mean double means not twice, but an extra change will be there, because see, we cannot predict the change as the exponent changes. Hope you understand a bit. So if we keep a function in its exponent, it is not easy to find the rate of change, right? So if we keep a function in its exponent, it is not easy for us to find the rate of change, because there will be unpredictable change, right? Okay, right? What do you say, Tom? I can get you. What you said? You said something, Tom? Okay. So see, so basically, you are not allowed to keep exponent as a function and differentiate. You will not get the rate of change, because see, the rate of change we cannot
Hello,
predict
my
that
dear
one,
children.
right? Because power is a function. That's why. So we just want to get rid of this function, right? Unmute.
Hello, sir.
Hope you understand. These are exponential functions, and you are not allowed to differentiate functions with an exponent as a function. Why?
Because that is also a function.
So as x changes, the change in this will be not predictable actually. You understand? Because huge change will be there. That's why. Okay. So we are going to differentiate exponential functions, right? I think we have written there to differential exponential functions. We have to use logarithm. It's there
Yes.
written there or not? Okay.
Yes, sir.
Okay. So now right. Don't solve with me. I'll give you time, but write it at the problem. Find the derivative of x raised to x. Find the derivative of x raised to x. Okay. Anyway, we tried. That's all. So we make a discussion, and if you get something, that's good. If you didn't get uh, anything from that, don't worry. You can solve the problem. See. Anyway, we know to differentiate exponential function means function with another function in its exponent, we have to use logarithm, right? So they asked us to find the derivative of x raised to x at once. While seeing this one, we understood it's an exponential function. It is x raised to x. The power is a function, exponent is a function, it's an exponential function. Now, see, when you identify it as an exponential function, steps are all mechanical. The same step in every problem, right? It's like this. To differentiate an exponential function, we know we have to use logarithm. So, we will take this y. Let y equals x raised to x. Now, taking, see, it's an equation. We can do anything on both sides, right? We can add 2 on both sides. We can divide by x on both sides. Like taking log, we are going to take logarithm on both the sides. So what will become? Log y equals log x raised to x. So log y equals log x raised to x. This is the property. This is the fourth property, right? What? It is like a log a raised to b equals what? It is x log x. Hope you understand. Log a raised to b is b times log a. So using that property, what is log x raised to x? It is x log. Is that okay? Right? If you understand, you type there yes, so that I understand you understand. Right? Okay. Right. Now, see, now there is no power in the exponent. And exponent is not a function, right? So actually, we use logarithm to get rid of this one, right? Now it is the function, the product now. Now differentiating both sides with respect to x, like this, differentiating both sides with respect to x. So what? D by dx of log y, Meagle again online, equals d by dx of x log x. Meagle,
Log
d by dx of log y,
the please shut up. 1 by y by dx.
1 by y dy by dx equals, how you differentiate x log x log x, x log x?
X log. Mm, mm, 1 by x. 1 by x times
1 by x?
1 by x.
What I say? Derivative of x log x is 1 by x.
So 1 by x times
1 by x times.
x.
See, what kind of a function is this? This x log x.
X log x. അല്ലല്ലല്ലല്ലല്ല uv അല്ലേ d by dx of uv.
Tell me the derivative.
അയ്യോ എനിക്ക് കേൾക്കണില്ലല്ലോ.
Tell me the you differentiate. Tell me the derivative.
d by dx of x. ഒരു മിനിറ്റ്. എന്ന് പറയുന്നത് എന്തിട്ടാ 1 by x plus അല്ല log x plus 1 by
See,
x
we
plus
have
log x.
been discussing logarithm. I mean, differentiation these days. And I'm asking you, what is d by dx of x log x? And you're saying it is 1 by x log x. What's going on?
X times 1 by x plus
Uh,
log x
log x.
times 1. അത് വേണ്ട. X cancel 1 plus log x.
So dy by dx equals y times 1 plus log x, right? So when you get time, just go through this thing. Now see, we have taken this mute now. Dy by dx equals y times 1 plus log x. Now see, in the question there is no y. In the question there is no y. We have taken the given function as y. So you have to resubstitute, right? In answer, in the question, if there is no y, in the answer too there is no y. What is the doubt? You asked me a doubt. Who was there? I didn't get that. What? So dy by dx equals y times 1 plus log x. So y equals x raised to x, and we substituted. We have taken this term as y. So in the question there is no y. So in the answer too there must not be any y. So if you have taken this as y, you have to resubstitute y. What is y? So it's d by dx of x raised to x equals x raised to x times 1 plus log x. Right? So this is the derivative of x raised to x. You are not allowed to solve it now. Right? We will solve 4 problems. Right? We will solve 4 problems now, and after that you can solve. I'll tell you when to solve. See, d by dx of x raised to sin x. Sana, are you there? Sana? Sana? Megila?
Yes, sir.
Tell me how to differentiate this one. What kind of a function is this?
Sir, I can't see the board properly. It is blur.
It's my problem. It's the problem at your end. What's happening?
My problem.
So mute now. Haya.
Hello, sir.
Can you see this one?
Yes, sir.
Can you? What kind of a function is x raised to sin x?
Exponential.
Exponential function. So how you differentiate? Tell me the steps and I'll write. Come on.
Y equals x raised to sin x.
Let y equals x raised to sin x. Now what?
Take log on both sides.
Taking, I can write applying or taking log on both the sides. So what?
Log y equals log x raised to sin x.
This is like log x raised to sin x is like
Function.
see, this is an exponential function. I told you we cannot differentiate a function keeping another function in its exponent, right? Because there will be unpredictable change and we cannot find the rate of change if there is a function in the exponent. See, if it is x squared, See, only this x changes. If it is x raised to x, both the x changes, an unpredictable change will be there. Right? We cannot. It's not easy for us to find out the rate of change. So log x raised to x. You know why we are applying logarithm? To get rid of this function in the power. So log x raised to sin x is like log a raised to b. And what? It is
sin x log x.
sin x log x. Now what we do? Differentiating both sides with respect to x. Now mute. D by dx of log y equals d by dx of sin x log x. Sin x log x. We know this is an implicit function like d by dx of log y, 1 by y, dy by dx. As we differentiated a function of y with respect to x, 1 by y dy by dx will be there. And you know, this is product of two functions, sin x and log x. Derivative sin x first into derivative log x plus log x into cos x. Right? Now, dy by dx equals, we'll take y to the right side. At y times sin x by x plus log x cos x. Right? Now, I told you in the question there is no y. We have taken this given function as y. It's not allowed. So in the answer 2, no y. So what? D by dx of x raised to sin x equals x raised to sin x. Then y? X raised to sin x. Sin x divided by x plus log x times cos x. Right? Hope you understand. Still, it's not time to solve problems. Angel.
Yes, sir.
D by dx of sin x all raised to x. Tell me, what kind of a function is this?
Exponential function.
Why?
Because
What are you saying?
the power is function.
What do you do to differentiate? Tell me.
Let y equals
Ah,
sin x whole raised to x.
Now,
Take log on both sides.
taking. See, we will write taking. If you say take log on both sides, you are asking something to take. You are asking someone to take the log, but you have to take log yourself. So taking log on both the sides. Tell me, come on.
Log y equals
Ah,
log of sin x whole raised to x.
carry on.
1 by that is 1 minute.
Apply the property of logarithm. See, you can
X.
differentiate only if there is no function in the exponent. To avoid the function in the exponent, we are using log. So, come on.
X log of sin x.
X log of sin x. Right? Okay. Now, both sides
Differentiate
with respect
to x.
see, it's enough when you write like this. Right? Differentiating BSWR means with respect to. So, I'll read it like. Now, what? D by dx of what?
Log y.
Equals
D by dx of x.
x log
Sin x.
sin x. What's the derivative of log y?
1 by y dy by dx.
Dy by dx. Tell me what kind of a function is this?
We have to use that product rule.
Product rule and see, it's a product basically. Product of
Product
whose
of
product of x and log sin x.
yes.
And x is a function. Log sin x is
1 by sin x.
I'm asking you, log sin x is what kind of a function is log sin x?
Logarithmic.
Uh,
Eh?
what kind of a function is log sin x? What you used to get with log?
X.
Now you have sin x. So what kind of a function is this?
Type 3.
Function of a function.
Yes.
Yeah, that's answering. See you either. So tell me how to differentiate.
X
D by dx. I'll write d by dx of
log sin x plus log sin x into d into 1
equal x times. How to differentiate log sin x? Tell me the derivative.
cos x into
Hmm.
1 by sin x plus log sin x.
Times 1. Okay. Now we'll take, mute. Now we'll take this y to right side. dy by dx equals y times y taken to right side. X cot x. Am I right? X cot x. Cos x by sin x is cot x plus log sin x. Right. Now, to tell you, in the question there is no y. We have taken this y. So we have to substitute for y. So what? D by dx of, what is y? It's sin x all raised to x equals sin x all raised to x times x cot x plus log sin x. Right? Hope you understand. Right? Now, let's solve problem. Find the derivative of x raised to x. Find the derivative of x raised to x. Find the derivative of x raised to x. See, d by dx of x raised to x. Now you two can solve. Right. Now we know this is an exponential function, and the power of x we have another function. So exponent is another function. We call it exponential function. So to start with, let y equals x raised to x, taking log on both sides. Log on both the sides. Why we take log on both sides? Why we take log here? Right? Because this is an exponential function. Keeping a function in the exponent, we cannot differentiate. So we just want to get rid of this x in the power. So log y equals log x raised to x. This is like log a raised to b equals what? B log a. Now differentiate right. Differentiating both sides with respect to x. What do you get? D by dx. I'll write over there. D by dx of. You two can solve. Come on, you two try. Log y equals d by dx of x log x. Be thorough with the types of differentiation. Log y is 1 by y dy by dx. X log x is a product. You can you have to use products over there. See, no steps are required, but you can write the result straight. X times derivative log x is 1 by x plus log x times the derivative x is 1. X is cancelled. Dy by dx equals y taken to right side. Now what? 1 plus log x. Don't forget to substitute for y. So d by dx of x raised to x equals x raised to x times 1 plus log x. See, if you refer in the list of standard results, it's there. I have given you this result. D by dx of x raised to x equals x raised to x times 1 plus log x. Right? When you finish solving this one, type yes there. We'll move to the next question. Next, find d by dx of x raised to sine. D by dx of x raised to sine x. So what? D by dx of x raised to sine x. This too is an exponential function. So when you find exponential function, think of logarithm, right? See, I told you why we are using logarithm. What is the problem when we keep exponent as a function, right? Open up to all these things, right? So that's the base actually, the theory. If you don't know the theory, still you can solve problem, right? So let y equal x raised to sine x. And there's one more thing. You know why we are taking y equal to y equals x raised to sine x? See, we know to avoid this sin x from power, we have to apply logarithm, right? And straight, we cannot apply log there. See, you have a 2, and you see, I'm going to apply log, and it's log 2. See, log 2 and 2 are different, right? So you cannot apply log straight. You cannot apply log on both sides, right? You cannot add 2 on both sides. So before applying logarithm, it must be an equation, right, to apply it on both sides. That's why we have taken y as, right, this. Now, hope you understand. Taking logarithm on both sides. Godwina, mute your microphone. Taking log on both sides. So what? Log y equals log x raised to sin x. This is like log a raised to b. And what? Sin x log x. b log a. So sin x log x. Now differentiating both sides with respect to x, we get d by dx of log y equals d by dx of sin x log x, right? What is d by dx of log y? 1 by y dy by dx, right? Equal sin x log x is a product. So we'll use the product rule. Sin x times 1 by x plus log x times derivative of sin x is cos x, right? Now we'll take y to right side and will become dy by dx equals y times sin x divided by x plus log x cos x. It is log x cos x. I can write cos x log x, the same, right? Now don't forget to substitute y. So d by dx of x raised to sin x equals x raised to sin x into sin x by x plus log x cos x. Right. That's it. Try this problem. Finish solving this one. Finished? Yes. Next. D by dx of x raised to cot x. So is this d by dx of x raised to cot x. Right. So you can understand, you can identify this as an exponential function. We have to use logarithm in such cases. So y equals x raised to cot x, taking or applying log on both the sides. So what? Log y equals log x raised to cot x. This is log, like log a raised to b is b log a. What is b? Cot x times log x. Now, see, now there is no function in the exponential, in the exponent, so there's no problem. You can differentiate. Differentiating both the sides with respect to x. It is enough when you write like this, right? It's taken for granted. Now, d by dx of log y equals d by dx of cot x log x. What is d by dx of log y? It's 1 by y dy by dx. See, if you use logarithm, the left side will be like this, there's no doubt. It will be like this, equals cot x times, this is a product basically. So we use product rule. First function times derivative second 1 by x plus second function log x negative cosec squared x, negative cosec squared x. Now let's take y to right side. So what? Dy by dx equals y times cot x by x minus log x cosec squared x. Right. Substitute for y. So you substitute. So you can write this function first. Like you can write it as cosec squared x log x or log x cosec squared x. Makes no difference. The same. Don't forget to substitute y here. Y is x raised to cot x. And when you finish solving this one, tell me yes. Okay. So next. Find d by dx of sin x all raised to x. D by dx of sin x all raised to x. Again, exponential function. We call you exponential function means exponential function. So we use logarithm. For that, we need to get an equation first. Y equals sin x all raised to x. Now what? Taking logarithm on both the sides. So what? Log y equals log sin x all raised to x. This is like log a raised to b, right? And c is b log a, right? So x log sin x, right? So now there is no function in the exponent. For this purpose, we are using logarithm. We are taking logarithm. Now there is no problem differentiating both the sides with respect to x. Now what? D by dx of log y equals d by dx of x log sin x log sin x, right? I think you remember the way we discussed the differentiation of function of a function, type 1, type 2, type 3. At that time, you're saying the derivative of this one log sin x straight, right? Now 2, you have to say the same and the same speed. Derivative log y is 1 by y dy by dx equals, this is the product, x times derivative of log x is cos x 1 by sin x. Because it is function of a function, we have to write the derivative of sin x first, it is cos x, log sin x is 1 by sin x, plus log sin x, the second function, we are using product rule, times 1, derivative of x is 1. Now, we will take y to right side, dy by dx equal y times x cot x, am I right? Cos x by sin x is cot x plus log sin x, and for you, don't forget to substitute y. Y is sin x all raised to x. See, you're not allowed to write a y in the result. So substitute for both the y on left and right. When you finish solving, let me know. Come on. So that's logarithmic differentiation. Okay. Now, see a problem for you. D by dx, find the derivative of d by dx of, find d by dx of tan x all raised to x. Try yourself. Tan x all raised to x. Find d by dx of tan x all raised to x. Come on, try. You have 2 minutes. Godwina, unmute. Godwina,
Hello, sir.
what's going on there? Are you
My
solving
net
problem?
is not clear.
Eh?
Net is not clear. I can't see the board correctly.
When you complete this, tell me. Don't forget to substitute this for this y. Okay. So the answer is, it must be like this. D by dx of sin x all raised to x equals sin x all raised to x times x cot x plus log sin x. Actually, logarithmic differentiation is very easy because steps are all the same. There's no change. Right. Next. Fine. Now we are moving forward. Right. Fine. D by dx of tan x all raised to sec x. Tan x all raised to sec x. D by dx of tan x all raised to sec x. So listen, d by dx of tan x all raised to sec x. Right? We know plainly it's clearly an exponential function because exponent is a function. So we know we keeping this thing here, we cannot differentiate. Right? We will not get the rate of change. Okay, so what we do, we will apply logarithm for y equals tan x all raised to sec x. Right? So we'll take log on both sides. So taking log on both the sides, what log y equals log tan x all raised to sec x. This is like log a raised to b. A is this, b is sec x. So b log a means sec x log tan x. Sec x log tan x. Hope you understand. So log y equals sec x log tan x. Now there is no function in exponent. We can differentiate. We can find the rate of change. Differentiating both the sides with respect to x. So what? D by dx of log y equals d by dx of what? Sec x log tan x. Right. You must understand this as a product. Right. Product of two functions. The first function is sec x, while the second function is log tan x. First function sec x, second function log tan x. Where this is a product and log tan x is function of a function. Right. What's the derivative of log y? It's always like 1 by dy by dx equals sec x is the first function. We are applying Not so. What's the derivative of log tan x? It is sec squared x times 1 by tan x. Am I right? Sec squared x by 1. So log tan x is function of a function. We have to write the derivative of tan x first, sec squared x times derivative of, log is 1 by tan x plus second function log tan x times what is derivative sec x, which is sec x tan x right here, sec x tan x. No further simplification on the right side is possible, right? Nothing. So what is log tan x times sec x tan x? Or better right, sec x tan x times log tan x, right? Now, if you want, you can write this 1 by tan x as cot x. Take y to right side and substitute for y. So the answer must be like this. Dy by dx of tan x all raised to sec x is the question, equals tan x all raised to sec x times sec cube x cot x plus log tan x times sec x tan x. Right? The same. Hardik, you finished solving this question? Hardik, finish this one or not? Are you there? Yes. You understand this one, Hardik? Can you solve problems like this? Okay, good. Right. Now, let's continue. Right. We will solve one more problem. Right. Now, after that, you can solve problems yourself. Right. Okay. Right. Shifa more.
Hello, sir.
Yes. We're going to find the derivative of sin x all raised to x plus x raised to sin x. We'll find the derivative of sin x all raised to x plus x raised to sin x. Tell me how. Tell me what kind of a function is this?
Exponential function.
So we have to apply logarithm, right?
Yes.
Tell me how.
First, we have to find derivative of sin x all raised to x.
First, we have to find the derivative of sin x all raised to x. Then
After that, x x raised to sin x. Then add both.
Then we have to add both, right? So that's very good. Very good, Shifa. Right. So listen. See, some of you may think like this. Let y equals sin x all raised to x plus x raised to sin x, right? And then you apply log on both sides. It's wrong. You know why? I'll show you. Log y equals log sin x all raised to x plus x raised to x. Now you're stuck. You're stuck, right? We cannot proceed. See, log a plus b is not log a plus log b. Log ab, if it's log ab, we can write log a plus log b. You can understand? I think you can understand this one. So log sin x all raised to x plus x raised to sin x. If you write like this, you cannot proceed because we cannot convert this as sum of two functions. Hope you understand. If you understand, see it, we cannot take it like this. At least if you understand that, type yes there so that I can understand. Yes. Okay. Okay. So in such cases, if it's the sum of two functions, we know it's exponential. We cannot take it as the whole thing as y. So what we do? We will do like this. Equals what? D by dx of sin x all raised to x, which you know this, how to find the derivative. Plus what? D by dx of x raised to sin x. You know this too. You know this one. You know this one too. So if it's sum or difference of two functions, you have to write them individually, separately. Now take this as y, find the derivative. Take this as y, find the derivative, and find the sum of derivatives. That's your result. So what? Let y equals sin x all raised to x. Now taking both sides, like you will get an answer. Again, let's y again. There's no problem because in the answer there will not be any y. Y equals x raised to sin x. Take log on both sides, differentiate, and the answer is this one plus this one. If you understand, if you can solve this one, type yes. Tell me. Type yes. No? Yes. Tom can. Okay. 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 Yes. Right. Come on. Come on. Try. See. Wait. Before that, we are almost there to finish this one. So, page 178 of NCR. Page 178 of NCRT. Problem. Exercise 5. Exercise 5.5. Question 3, 4, 6, 7, 8, 9, and 11. 3, 4, 6, 7, 8, 9, 10 also. 10 and 11. 10 and 11. Your homework for today. I told you. See, anytime you can call me or ask me a doubt, but see, 9 to 9:45 exclusively for you. Okay, now solve this one. Okay, I think it's time. Do one thing. You told me you can solve this one. Try the problem yourself. If you want to ask something, you can now. Any doubts in this? Anything to ask? Logarithm, exponential function, like you can ask now. Otherwise, you solve it as a homework again, and that's all. If there is nothing to ask, you can log.